Good morning, students. I am Professor Arvind Mundeviha, Department of Mechanical Engineering. Welcome you to the design lab. And today we are going to start with the experiment deflection of curved beams. Okay. So the main experiment of the main aim of this experiment is to measure the vertical component of a deflection of a curved beams at a desired point and measure the strain value on the strain indicator. So mainly what we are going to do in this experiment is we are going to put the loads on the curved beams and which will be subjected to the strain, and we are going to note down the strain of those curved beams at a different weights in the strain indicator, and we are going to plot the graph of load versus strain. So in this we have different types of curved beams in this apparatus. Okay, mainly we have angle divot, circular ring, curved divot, quadrant and semicircle. So what is curved beam, which you have already studied? A curved beam is having a curved axis which is elevated from its straight line. So such beams are called as a curved beams. Okay. Next, in the experiment we are going to put the loads on these different curved beams and we are going to note down the strain in the strain indicator. So this is the experimental setup of curved beams, and here we can see the different curved beams which are given here. So the first one is the angle divot. This is the angle divot. This is the circular ring. Okay, and this is the curved divot, and this is the quadrant, and here we have the semicircle. So these are the 5 different curved beams what we are having here. Okay, and on each of the curved beams you can see there is a package. So this is nothing but the strain gauge which is fixed on these curved beams. Okay, the strain gauges indicate us what is the strain induced in the curved beam when it is subjected to the vertical loading. Okay, and here you can see at the end of each of these curved beams there is a one hook is provided. So on this hook only we are going to apply the load. Okay, and this is the loading span which is given here, and the weight of this loading span is also be considered, and weight of this loading span is 150 grams. This loading span is used to hang over this hook, and on which we are going to apply the different loads. So here you can see we are having different weights over here. Okay, we are going to put these weights on these span like this. Okay, I'm just showing you so how to apply these loads, how to use this span and the load. This is how we are going to apply the load. Okay, for the required loads. So this is about this setup, and next we have a strain indicator here. Okay, so these strain gauges are connected to the strain indicator. Okay, so this is the digital display what we have, which is going to show us what is the strain induced in these curved beams. Okay, so when we are using the first one, angle divot, the channel selector should be on the number 1. Okay, and if you are using say circular ring which is number 2, so you have to change this channel selector. So when you change that channel selector, you can see again this digital display varies. Here you can see at number 2 it is 93. When you rotate it, it will display some other number, okay, randomly. So now it is on channel 3. As we are using the angle divot which is the first one, I will bring this to first one. Okay, now you can see that it is not showing a 0. Okay, but whatever the minimum reading is there, that only we are going to consider it as a 0. Since it is deflecting, I am adjusting it to the round figure using this GF, and here we have a course which is used to change to the big numbers. Okay, if I change that, you can see it has moved to the 400. Now it has moved to the near about 800. Okay, so to jump on the higher side we use this course. Okay, and for little variations in the number we use this GF and the fine tuner. Okay, so now with the 0 weight it is showing as a strain value as a 50. So this we call it as a indicated strain. Okay, now when I put this span, okay, which is carrying of weight of 150 gram. Okay, when I put this it is showing 66. Okay, so indicated strain is 66 and actual strain is 66 minus 50, which is about 16 okay, microstrain. So this is how we have to carry the readings. Okay, so if I say I am applying one load on this, say 50 gram it is, say now it is 71. So previously it was 66 was the indicated strain, and sorry, 66 the indicated strain is now 71. Okay, the previous one was 66, so you have to subtract that, so it will be 71 minus 66, so that will be 5 microstrain. So this is how we have to take the readings. Now what we'll do, we'll apply different weights and we'll measure the strain. So that is how we have to conduct this experiment. And later on what I will do, I will remove this. Next I will change this channel selector, and here you can see the number has changed. I will try to adjust to the next number. We'll take it as a round figure. Now it is showing 100. 100 is a 0 microstrain for us. Okay, so next when I apply this load on the circular ring 2, that is channel number 2, okay, the circular ring, the weight of the span is 150 gram. So for 150 gram it is showing 103 microstrain. So indicated is 103. Okay, so actual is 103 minus 100 will be 3 microstrain. So actual strain will be 3 microstrain. How we got that? 103 minus 100. So it will be 3 microstrain. So next we will keep on adding the different loads. We keep on adding the different loads. So now it is showing 106 microstrain. So this is indicated microstrain 106. Okay, so actual will be 106 minus 100. So total is 6. So in actual strain is 6 microstrain. So this is how we are going to take the readings on a different curved beams. Okay, now we will see one of the reading for the angle divot. So here we have the reading for the angle divot. So as we saw in the experiment, for the 0 weight it was showing indicated strain as a 50 microstrain. So we consider it as a actual strain, we consider it as a 0 microstrain. So for 150 gram, that is for the weight of the span. Okay, so for the weight of the span it was showing indicated strain as a 57. So we need to find the actual strain. So how to find actual strain? 57 minus 50 will give us actual strain, that is 7. We will add 100 grams. So it will become 250 grams. Weight of the span plus 100 gram. Both together will become 250 grams. So for this 250 gram, it was showing indicated strain as 61. So how to find actual strain? 61 minus 50. So it will give 11. So this is the actual strain in microns. Next we will add one more 100 grams, so it will be 350. Indicated strain is 66. How to find actual strain? Indicated 66 minus 50, so it will give 16. This is the actual strain. So for this, like this, we will add weights to the beam, and we will get indicated strain, and we subtract with the 50 and we will get the actual strain in terms of microns. So these are the readings. So this is only we have taken it for the angle divot, that is number 1 angle divot. So like this we have to conduct the experiment for different curved divots like a circular ring, curved divot, and a quadrant and a semicircle. After getting this table, we will draw the weight versus strain graph. Here you can see in the x-axis we have weights in the graph. So this is grams. Okay, so we have the weight up to the 1000 grams. So you divide into this 1000 grams, and microstrain for this particular we have up to 96, okay, or 46 we have. So you on y-axis you consider the microstrain 20, 40, 60, 80 and 100, and for the different weights what is the strain indicated that you plot on the graph. Okay, so this completes the weight versus microstrain graph. So this completes the set of experiment for the angle debate. So next, when you take the reading for the circular ring in the different table, the same graph can be plotted in the same graph only, okay, indicating this as the angle debate, next one as the circular ring, okay, the curve debate you can draw the quadrant and you can draw the semicircle. So this is how you have to complete the experiment. In the student group, the readings will be provided for you. The student what has to do, he has to plot the graph for this and he has to complete the table. Okay, readings will be given, like weight and indicated strain will be given. Based on that, student has to calculate the actual strain and then he has to draw the graphs, so to complete the journal write-up and the experiment. Okay, so this is the completion of deflection of curved beams. Thank you.